After NASA's press conference and weeks of new ATLAS observations, people have been flooding comment sections with questions. Loeb just sat down for an extended Q&A and cleared up everything. Let me break down what we learned. Why was NASA's press conference so disappointing? The question everyone's been asking since that press conference dropped. Loeb doesn't hold back. He says NASA made two major mistakes. First, they downplayed the mystery instead of embracing it. When you hold a press conference about an object interesting enough to warrant NASA officials discussing it publicly, you should focus on why it's puzzling. What are the big questions? What makes this worth our attention? Instead, they tried to convince everyone it's just a familiar type of comet from a different environment. Nothing unusual here, move along. But here's the problem. There are mysteries. Lots of them. 12 documented anomalies that don't fit natural explanations, and that's what the public actually cares about. People want to see science as detective work in progress, not officials lecturing from a position of already knowing everything. Second mistake, holding the conference at all. The data didn't provide significant new information. The images were blurry, degraded by camera jitter and object motion. They held the high-rise image for 45 days during the government shutdown, building expectations, then released something that didn't deliver much substance. But there was one fascinating detail buried in that high-rise image that NASA didn't emphasize. The glow around ATLAS appears elongated in the direction of motion, not toward the sun as you'd expect from sublimating ice. There's a plume of something preceding the object ahead of it in its trajectory. For a natural comet, that makes no sense. Material should trail behind or be pushed away from the sun by radiation pressure. But this glow is leading ATLAS, lighting its path forward. Loeb's interpretation? If ATLAS is technological, this could be a beam of particles or light designed to clear the path ahead. At 67 kilometers per second, micrometeorites become serious hazards. One solution? Illuminate obstacles with a light beam, charge them, then deflect with a magnetic field. Advanced spacecraft might use even more sophisticated methods we haven't imagined. Could the WOW signal have been sent to ATLAS? This question gets at something most people hadn't considered. We assume the WOW signal, if it was artificial, was meant for us. But what if it wasn't? It's entirely possible the signal was communication sent to ATLAS from its point of origin. In 1977, when the Big Ear telescope detected that 72-second burst, ATLAS was about 3 light days away, roughly 600 times the Earth-Sun distance. Transmitting that signal would have required about a gigawatt of power, equivalent to a nuclear plant, feasible for an advanced civilization. The 9-degree offset between the signal direction and ATLAS's arrival trajectory, that could be explained by ATLAS starting from a slightly different position than where we first detected it, or by the signal originating from a different location in the same stellar system. Or it could be complete coincidence. We don't know. But the possibility that we intercepted someone else's message to their probe is genuinely intriguing. Are mini-probes being released? The question on everyone's mind after those perpendicular jets appeared. Loeb's answer is carefully measured but direct. It's the fundamental question right now. We're seeing hints in multiple observations. Jets pointing in directions that don't align with the sun. That X pattern visible across 1,000,000 kilometers. The glow structure in the high-rise image. All of this could indicate smaller objects departing from the main body. Now, even if ATLAS is a massive spacecraft, it makes sense that it wouldn't maneuver significantly itself. It's enormous, 33 billion tons. Moving that much mass requires tremendous energy. The smarter approach would be releasing smaller probes towards specific targets while the mothership maintains its primary trajectory. So the critical task for the coming weeks is monitoring for new objects, not just near ATLAS, but near Earth and Mars. Loeb specifically asked NASA to search their rover and orbiter data around Mars for any new satellites that appeared unexpectedly. If we find small objects that arrived near Earth or Mars and trace their trajectories back to ATLAS, that's a technological signature. Natural icebergs fragment into ice chunks that sublimate and disappear. They don't deploy objects on ballistic paths toward planets. Why not send a signal to ATLAS? People keep asking this. The answer isn't about technical feasibility. Signals travel at light speed. ATLAS moves at 1/5000th of that. We could easily reach it. The question is purpose. If ATLAS is just a rock, what's the point? But if it's technological, do we risk irritating whoever sent it by beaming powerful signals at it? There's also the practical consideration that we can learn far more by observing it with hundreds of telescopes than by attempting communication and waiting for a response that may never come. What we can't do is use radar. If Earth had been in position 6 months earlier, we would have been as close to ATLAS as Mars was, about 50 million kilometers. At that distance, with ATLAS's large size and 16-hour rotation, we could have used radar systems to map it in 3 dimensions. But we were on the opposite side of the Sun during its perihelion passage. The geometry didn't work out. What's the plan going forward? This is where it gets concrete. Loeb's waiting until mid-December to update his ranking on the Loeb scale, because a flood of new data is coming. Making predictions now would be premature. The Webb telescope can search for heat emissions from ATLAS that can't be explained by solar illumination alone, potential evidence of an internal power source or engine. Ground-based spectroscopy will measure jet velocities precisely, distinguishing between natural outgassing at hundreds of meters per second and artificial propulsion at kilometers per second. December 19th remains the critical date when ATLAS makes its closest approach to Earth. Hubble, Webb, and hundreds of ground telescopes will observe simultaneously with unprecedented detail. And perhaps most importantly, continued monitoring for any objects that separated from ATLAS. If we detect probes near Earth or Mars in the coming months, if we find new satellites that shouldn't exist, that changes everything immediately. The approach is methodical. Collect evidence like a detective. Test each hypothesis with new observations. Follow the data wherever it leads, even if that means accepting conclusions that challenge our assumptions. Stay curious. The answers are coming.